So so you have a non-empty set and a matrix D, basically every matrix D. So remind you guys that the matrix has three properties. So basically it's symmetric and greater or equal to 0, and if this is 0, that means that 2 points must be the same. The third one is the important one called the triangular inequality. So distance between x and y plus distance between y and z must be greater or equal than the distance between x and z. Okay, and then which one is the distance? Can be the distance. So 4 plus d is equal to d minus 1, d minus d absolute value d squared square root of d. Okay, so basically we check turn by turn. Okay. So I call it d tilde. Okay, so the first one, d tilde is 4 plus d. D, is it satisfied 1, 2, 3? Is it satisfied 1, 2, 3? So the answer is no. Obviously, suppose you pick 2 points that is the same, then you have 4 plus 0, which is 4, which is not 0. So the second fails. Basically, the first one is always success. Sorry, right? Because these are all symmetric. So basically, we only need to check the third and the second. Okay, and how about the C? So we just first deleted the obviously wrong question. So for C, this is d tilde defined to be d minus d, right? Basically this is 0, right? Because d is larger, d is positive or 0, right? So d minus absolute value d is 0, but this violate 2, right? Because any two different points will lead to d tilde x will lead to the distance 0. So C is also false. Okay, so the difficult part is B, D, E, right? So the D is a famous one, which maybe you guys already know, right? So D is the D square, right? Oh, let me use a different color. Right, so D tilde is a D square. Okay. So the famous, the easiest way is we use the Pythagorean 3, 4, 5. Suppose this is x, this is y, this is z, right? So let me see. Okay, maybe we don't use this. We can use like so we use the standard Euclidean space and on a real line. So basically, when d tilde is d squared, that means that x plus minus y squared plus y minus z squared must be larger or greater or larger than x minus z squared. And if you claim this is true, then what you get is this one. And I can delete this, delete this, delete this, delete this. This is okay. Delete this, right? This is d squared. So what will remain is 2y squared minus 2yx minus 2yz larger than 2xz for all x, y, z in R. But this is impossible because I can set y to be 0. I can set y to be the origin. Then this will lead us to x, z is larger than 0. If x is greater or larger than 0, then this triangular inequality can be satisfied. So once we know this, then we can create a counterexample. We just let x and z are at different size. So basically, suppose I choose x to be plus 2 and z to be minus 3 and y to be 0, right? Y is here. So basically, the distance from y and z is 2 square, and the distance from z and y is 3 square. But this is only for 13, and the total distance is 5 square, so it's 25. So basically, the triangular inequality is failed. Okay. So unfortunately, D is not our answer. How about B? So B is I think B is the hard one, right? Because there's you need to do some analysis to see whether this is okay. So exponential D minus 1 is larger than 0 because D is greater or larger than 0. So exponential D minus 1 is okay. It's positive, right? But we need to show that we need to ask, suppose I let D1 to be dxy, D2 to be dyz, and D3 to be dxz. So inequality tells you that D1 plus D2 larger than D3. So I want to ask, is exponential D1 minus 1 plus exponential D2 minus 1 larger than exponential D3 minus 1? Is this fact correct? Is this will lead to this? This is what we want to ask. And the answer is no. The answer is no. How do we show this? So suppose we have a Pythagorean triangle. This is 3k, 4k, and 5k. This is x, y, and z. So the left hand side is exponential 3k plus exponential 4k minus 1. And the right hand side is exponential 5k. Right. So it's obvious that when k goes to infinity, then this term will dominate these two terms. So that means when k goes to very large, then this triangular inequality cannot be satisfied. Right? Because exponential 5k will dominate the exponential 3k, power 3k, and 4k. So this cannot be the correct answer. So the answer is E. So when you do the square roots of the original distance, then it will be another distance. And why? So proof is that we want to show that suppose D1 plus D2 larger than D3, we want to show that square D1 plus square D2 is larger than square D3. Suppose this is correct, we want to prove this. So proof is simple that we start from the left hand side and we square it. So we get D1 plus D2 larger than plus 2 squared D1 and D2. And then this is larger than D3, right? Because this is positive, and then this is larger than this. So this is square root D3 squared. And then we take the square root both sides. We take a square root both sides. We get this one. So the answer is E. So this is a tricky problem. So the answer is E. And be sure to subscribe to my channel, and I will see you guys in next time.